Hey guys, welcome back. We are getting ready for exam 2, chapters 13 and 14 in dynamics, and I have a fun problem for you. So here's the situation. We have two blocks, A and B, hanging from a cord, and we release them at point 0. Block B comes down, block A goes up. Makes impact, so this cord goes through this collar C, makes impact perfectly elastic impact, meaning the coefficient of restitution is 0, comes up, stops, because at first it's the B side is heavier, but once A picks up C, then the A side is heavier. So it comes up, it stops, then it comes back down. We are asked to find the velocity of the AC combo immediately after impact, and then we're asked to find the height that AC get to. And finally, we're asked to find the value of x when the cycle has completed, right? So it's going to come up, it's going to stop, it's going to come back down, and we're asked to find those. So it makes sense to number these positions. So let's call this position 0, we'll call this position 1, call this up here position 2, and when it comes back down, let's call that position 3. Right, so let's get to it. This is a fun problem. I like this one. Alright, so I'm going to go ahead and leave this in the bottom right hand corner. It gives us a handy way of keeping track of it. So again, the given coefficient of restitution is 0. X is 1.7, so that is how high up A has to go in order to get there. And most of this is done with the conservation of energy. So if we draw A and B in their home positions, let me find a better pen here. Okay, so this is A, and we're calling this point 0. Right, so this is A, and it is going to come up to position 1, right? So this is 1.7 right here. 1.7 to position 1, and similarly, B is at its position 0, and it's going to come down to its position 1. So we can use the conservation of energy to get there. The system is released from rest, so let's see, T0 plus V0 equals T1 plus V1. Alright, it's released from rest, so there is no T0. And if we rearrange this, then we get that T1 equals V1 minus V0. Well, we can actually shortcut this and just assume that T0 is, or excuse me, that 0 is the has no value, and I'll show you what I mean in a second. It's just a shortcut. We could do it either way, but let's do it this way, and I'll show you what all that means. So the kinetic energy is 1/2 mv squared, so the masses are connected by a rope, right? So what that means is that the velocity is the same for both sides. So 1/2 mv is ma plus mb, and that's going to be v1 squared, and that's going to be equal to the potential energy of both of these. So if we think of the lowest point on this, the bottom of the 1.7, if you will, as being 0, then we have ma, and what is it, mgh, so mag, and then h in this case is 1.7, so this is gained potential energy, and B has the lost potential energy, so that's minus MB G 1.7. Okay, so let's see. This is 5 and 6, so 11 halves. V1 squared is going to be equal to, let's see, G 1.7, so let's say 1.7 G, and then this is 5 minus 6, so minus 1, and this is already minus, so there we have it. So then V1 is equal to what? The square root of, looks like 2/11ths, not 2 there, 2/11ths times 1.7, and that's what, 9.81. Okay, and let me run that through the calculator and see what we get. See, the square root of 2/11ths times 1.7 times 9.81. That gives us that V1 is 1.74132 meters per second. Okay, but keep in mind that this is, yes, it's at this point 1, but this is immediately before we make contact with C. So let's let me do this. Let me put this as star, right? Because it's not really the value that we're looking for. It's an intermediate value. And let's make some room. Okay, and I'll just write this up at the top. V1 star is equal to 1.74132 and meters per second. Okay, so here we have basically impulse, right? So plus some sort of an impulse, and well, do it the easy way, we'll say MA. So first things first, what we're going to do is we're going to look at both sides, right? So let me actually draw this out. It'll be a little bit easier to understand. So this is MA, and then plus some sort of an impulse, right? And that's going to equal both of them, right? So here we have a V, this is going to be V1 star. This, we can just summarize this to be T, or, well, yeah, T is fine because it's the tension, T times delta T, and that's going to equal MA plus MC times the V1 that we're interested in, right? So, what does this end up being? This is MA plus, MA V1 star plus T delta T. And remember that impact is just really fast impulse, right? So this actually works. And that's going to equal, and what is MA and MC? That is 8. So we'll just say 8 times V1. This is 5. Okay. All right. So if we look at the B block, then we don't really need this. It's nothing's changing. But what we can say is, so this is for A and C. For B, then it's MB and then V1 star, because they're moving at the same rate, and then this is going to be minus T delta T equals, and we have 6 times V1. Alright, so if we add these together, then notice here the velocity is according to, because this is no longer energy, right? So we're thinking in terms of the direction and they're moving in the same direction, right, because the rope is tied together. So if we add these together, then we get 11 times v1 prime, this goes away, equals 14 times v1. So then v1 is just 11/14 of this v1 star, which is 1.74132. And what does that equal? Let's see, that's times 11 over 14. And that gives us 1.368 meters per second. And this is the value we need, right? So let's store this. We'll put this away for safekeeping up here. So we'll say V1 equals 1.368 meters per second. Okay. All right. Now we're crossing through and just looking at this here. So we've gone through position 1, and now we're going up. We're slowing down, so we're going from position 1 to position 2. So if we draw that, then what do we have? We have A and C. Okay, A, C, right? And we're in position 1, and we're going to position 2. And similarly, B is in position 1, and it's going to position 2. So again, we can use the conservation of energy. We get to do that because, you know, gravity. So what we have T1 plus V1 equals T2 plus V2, right? And refresher, we're going up to where we stop, right? So T2 is going to equal 0. T1, and I'm going to do this, so in the last calculation when we had this, I noted that we could just sort of disregard it and treat the change, right? So now I'll expand this out and we'll be a little more formal. So writing this, we have T1 equals V2 minus V1, right? And what is T1? T1 is 1/2 of mb squared, and that is these m's and this m, so 1/2 of, I guess, 14 v squared. And which v? v1 squared. Okay, so 7v1 squared. All right, and that's going to equal, now we'll split this up and we'll say AC, so MAC, MA plus MC, okay, and we're going up, so the, let's see, the V2 is going to be, let's see, G, and we're going to say H, right? So from an altitude point of view, what we can do is we can say that this is 0 and this is H, right? So we're going from 0 to H. Likewise, on the B side, we can go from H to 0, right? So V2 has 2 components to it, so I'll put them in brackets, and so we're adding, and here we have B2, let's see, this one's at the bottom, so this is V2, well, sorry, 2 is H, and then MB, G, and this is going to be 0, right, so this is V2, and then minus, and then V1 is MA plus MC, right, times G, and in this case, V1 is 0, right? Okay, and then plus MB and G, and V1 is H, So the zeros cancel. So what we end up with on this side of the equation is MA plus MC is 8 GH, and then minus 0, so that is 6 GH. Okay, so 7 V1 squared equals 2 GH, and we have H that we're after, so H equals 7 halves, I guess 7 over 2G, so make this a bigger fraction, 9.81. V1 squared is 1.368 squared. Okay, and what does that give us? Well, let's see. 7 halves times this guy squared divided by 9.81. Alright, and that gives us 0.668 meters, right? Okay, sweet. So now we have B. Alright, so let's write this up here. We have B. Okay, H equals 0.668 meters. Alright. So we're at position 2. And let me just blow this up again so we can look at it for a second. Alright, so we're at position 2, and we're going to come back down, and then we're looking for position 3. So just because this is a frictionless system, that means that the velocity that we return with is the same as the velocity that we left with, right? So that 1.368 that we found, that is going to be the velocity when we return here, right? So what we can do is we can actually go from 1 to 3, right? And just sort of go back and go from there. So let's try that. So we're going from, let's see, we have A, right? And now we have returned to position 1, and we're going to position 3. Right, and this is A. Okay, and similarly with B, we return to position 1 and we are going to position 3. Okay, and again, call this 0. We'll call this, let's call this something different. Now we'll call this H3. So 0, H3. Okay, and so T1 plus V1 equals T3 plus V3. Okay, and we are going to the point where we stop. So go 0, and again, I'm going to go back to shortcutting the potential energy due to gravity. And so what do we have? This is the 1.368, so our total energy here is going to be 1/2, it's mv squared, so ma plus mb times v1 squared is going to be equal to our potential energy, so mag, and now we're coming down, so this is going to be minus H3, then plus MB, G, H3. Okay, and the difference on this side is the masses, right? So 6 minus 5, so that is GH3 on this side. GH3 here, this is 11, so 11 halves. V1 squared, we're looking for H, so we just divide G, so put a G there. put back the poor half of h3 that I took with me. And what do we have? We have h3 is equal to 11 times 1.368 squared over 2 times 9.81. Right, and remember, and notice that interestingly enough, the only difference between this outcome and the last one was that in the last one this is 14, I believe. Oh no, I'm sorry, this was 7. Right, so so this was 7 halves, and what we can just notice is that this is going to be a little bit lower than that one was. So we get this equals 1.049 meters. There we go. Alright, so C, H3 equals 1.049 meters. Alright, so I hope that was helpful. Oh, wow. Hold on. Looks like we have a little bit of focusing issues here. Come on, work with me. There we go. Now everything came into focus. Alright, again, I hope this was helpful, and I will see you in the next video.